All right, so we are going to go into fractions. Get a little overview of what our fraction is. We'll go into adding, subtracting, multiplying, and dividing fractions, simplifying fractions, things of that nature. And we'll do it in this video. Here we go. Let's start with equivalent fractions. Okay. A little model action going on here. A fraction basically has what's called a numerator, a denominator, and there are numbers in there, but they tell a story. They tell you something about what's going on. So here I have this shape. I cut it up into 4 pieces. Okay. The bottom number, the denominator, if you think about this model that I've done, kind of up into pieces, the bottom number tells you how many pieces make a whole. That's what the denominator does. So when you see a fraction, whatever the bottom number is, just imagine like a pizza. That's how many slices it was cut into. So if it's a 3, the pizza was cut into 3 slices, big pieces, right? If it was a 20, there's 20 slices on that pizza, all equal size, equal shape. Okay, imagine a perfect cut. What does the numerator tell me then? It basically will tell you how many pieces you have. So if I have a pizza that's cut into 3 slices, and its top number here is a 1, that means I have one of those 3 slices, meaning 2 of the slices are left over, or 2 out of the 3 are left over, kind of a deal. That's kind of what fractions are. Don't make it any harder than that. Okay? So, before you can compare or combine fractions, the denominators have to represent the same number of pieces. So it's very difficult, okay, to compare fractions if they are not the same, basically the same size, the same type. So if I have a different denominator, it's a different type of fraction. It's a different thing, okay? A denominator, like I said, of 20 is different than a denominator of 3 because the slices are different sizes and things like that. There's more of those in a whole. Think of a pizza as a whole. So what we need to do comparisons of fractions, like which fraction is bigger than the other one. Obviously, some are easy to determine, okay? Once you understand that, like the pizza analogy, so if I have 1 out of a slice of 3 on a pizza, a large pizza, well, that slice is pretty large. And if I have a large pizza that I cut into 20 slices, all of you really instinctively understand that that's a smaller slice, correct? So which one's bigger? Well, the 1/3 is bigger, correct? 1 piece out of 3 is more than 1 piece out of 20, right? Yes. So to compare these things that are more challenging, we need to start off by making the slices the same size. So when we do equivalent fractions, that's what we're doing. We're changing the number of slices. That's what we're doing. Okay? A pizza that has 3 slices, can I recut it into a pizza that has 20 slices? I can. It's a little bit challenging, but usually we do a nice multiplication process for it. But we change it to a bunch of different size, different number of slices. So here's an example of what I'm talking about. So here is a object that I cut into 3 equal pieces. If I shade this piece right here, then I have 1 out of the 3 slices. So this is a fraction of 1 out of 3. But what if I want 12 slices? What is this 1 slice I have going to change into if I cut this whole thing into 12? How many slices do I have out of the 12 to make it the same? That's really what the question is boiling down to. Okay? And so I need to then recut this. So if this is 3 slices and I want to cut it into 12 slices, I need to cut this up differently. There's a lot of ways I can do it. Here's one way I can do it. So you can start with what you had originally. This is the shaded part right here. And this is 3, so I can cut each of these again and then cut it down the middle. I can cut it this way because 3 times 4, so hold on a second. So what I did here is I cut it once this way, and here, and then I cut them all again. So, and then you can see that I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's 12. So there's 12 slices. And from here, the shaded part, which was equivalent to what I had over here, the shaded part, the smaller slices now, that 1 slice now got cut into 4 smaller slices. So this fraction is 4 out of 12. But this is exactly the same as this. So 1/3 is 4 twelfths. So how can I get to this without having to go through the drawings all the time? So the concept is the same for every single fraction. But I don't want to have to draw pictures and cut up boxes and shaded regions every time I want to do a fraction problem. Okay? Like in elementary school, you lingered on this for about a year. Okay? So we're going to do it now. How do I go mathematically and get to that point? Well, what did we do? Each one of these boxes turned into 4 boxes. And the reason for it is because 3 is related to 12 by a multiple of 4. So if I take 1/3, I'm going to change this so that it becomes a 12. So the question then becomes is, what do I need to change each slice to? How many more slices do I got to divide each of these into to get a 12? And using your multiplication knowledge, you know that if I multiply this by 4, 4 times 3 is 12. Cut each slice into 4 more, and you'll get a total of 12 slices. Okay? But in a fraction, by doing so, the top can't be 1, because you can see clearly 1 new slice is not nearly as big as the 1 slice over here. They're different sizes, aren't they? So I need to change these two. Remember, I had 1 slice over here. Well, if I have to cut every slice into 4 new ones, then I have to cut this slice into 4 new ones also. That's why we do the same to the top and the bottom. So 1 times 4 is 4. 3 times 4 is 12. And there's where your new equivalent fraction comes from. Another way to look at it is this. I'm going to keep 1/3 the same, and so the value is still 1 out of 3 overall, but I'm going to make more slices. So I can't change this fraction's value, but I can change the way it looks. By multiplying the top and the bottom by 4, think of a divide line here. What is 4 divided by 4? Well, that's a 1. 4 divided by 4 is 1. So literally, I'm just multiplying this by 1. That's why this is an equivalent fraction. So whichever way works for you, works for me. But this is a skill you must know how to do, how to change fractions, called equivalent fractions. Okay? And the process I showed you right here is exactly how you do it. What do I multiply to the bottom to get the new bottom? Whatever that number was, you do it to the top because you're recutting all the slices, the one you have and all the ones that were there, and then tell me what the equivalency would be. The reason why you have to do that is because that's how we do the next thing. How do I add or subtract fractions? Okay? Well, two scenarios are going to occur. The first scenario, the easiest one, and the one I'm really not going to talk about because it's easy, is when I have a common denominator. So what do I mean by a common denominator? Common means it's the same. They have the same denominator. So if I want to add or subtract two fractions and they're already the same size, so the denominators are exactly the same number, then I'm just talking about the same slices of pizzas. I'm just going to reorganize the pizza. Okay? And so here is mathematically the symbols associated with this scenario. So if I have a fraction where b is the denominator, and I add another fraction where b is the denominator, whether this is addition or subtraction, it's irrelevant. It's the same process no matter what. Okay? Well, if the denominators are the same, I have this many slices of this type, this many slices of this type. So when I add them, the only thing I add is the top numbers. You're not changing the type of slice you have. Okay? So the slice name stays the same. It's still cut into that size of a slice. But now I have this many of them. You just add the top numbers or subtract the top numbers. A quick example of this scenario, I'll show you real quick. I'll just make one up. It'd be very simple. Let's do 1/4 plus 2/4. See? I have 1 out of 4 slices of this type. I got 2 of the same size slice, 4s, right? So how many do I have? Well, it's still a 4th slice, isn't it? The bottom number is the name of the slice. It's a 4. The top tells me how many I have. I got 1 plus 2 is how many? I got 3 of those. Okay? So that's how that works. Very simple. Okay? So most of the time, and the issue most people have, comes when they have unlike denominators. If I have unlike denominators, I need to find the common one. I need to make them the same. Okay? I need to make them the same size. So I'm going to need to recut one or both of those fractions into a new fraction, an equivalent fraction, so that the bottom numbers are the same, and then I can use this rule. That's how you do fractions. Okay? So all the work associated with that concept, if you understand that concept, everything associated with that is about making them the equivalent fractions. Now, is it difficult to make equivalent fractions? If I tell you I want you to put the bottom number as a 12, you can do it. It's not that hard. So why do people have trouble with this? If that's easy to do, what's the hard part to do? Why do people have trouble with this the most? How do I know what number to use? That's the key. That's where people have the issue. Okay? And is that difficult? Not if you look at it the right way. A lot of people, when they teach you how to do all this kind of stuff, they start freaking out and they go through all these big, long litany of things to do. But I tell you right now, you know how to do it. You've been doing it since the 3rd grade. I know, it's amazing, huh? They just called it something different at that time. Okay? And hopefully, I'll catch some more of you guys on this as we go along, okay? Unlike denominators, we need to make them the same. Okay? So, there's a lot of numbers that will work. You gotta understand. No matter what the two fractions are, there's an infinite number of numbers that will work. But if you choose the wrong one, you will end up creating additional work for you. So what we want to do is we want to avoid that. To avoid extra work, we want to choose the number that causes the least amount of extra work. And that, since this is a denominator, you want to find what is called the least common denominator. This is what we're looking for, LCD. Least, the smallest common, okay? So the least common is the smallest number that denominator can be and still work. That's what this means. Because I can pick, like I said, an infinite number of them, but those numbers are going to get huge. They're going to get big, okay? I want the smallest one. I want the first one that's going to work. So how do I find that one, okay? Well, it's called the least common denominator. When you hit fractions, they call it that. Before fractions, they gave you work that you did in class, and they called it this. So an LCD is just the least common multiple. LCM. Oh my gosh. What's that? More acronyms, more things to remember. Well, what is the least common multiple? Well, you actually started this in like third grade. Multiple means multiplies, right? So the multiplying stuff, correct? So I want you to think back. This is how I'm going to show you how you did it in third and fourth grade. I want you to think back. Think back to the multiplication table. Okay? Multiplication table. Or your times tables, right? And I want you to, here's a little quick example. We're going to take the 4 and we're going to take a 5. And I want you to reproduce the multiplication table for the number 4. In other words, what is 4 times 1? 4. What's 4 times 2? Times 3 times 4, right? I'm just doing times table, right? Times 5 times 6 times 7, right? And I can keep going, correct? Do we agree? Now let's do the 5s. 5 times 1 times 2 times 3 times 4 times 5 times 6, right? And I can keep on going. Do you agree? These are multiples. Do we see this? All of these, so these are multiples for 4 and 5 because you got it by multiplying. See that? So you ready? Mind blown here. Are there any numbers that are common? Common means they're in both lists. Sometimes there'll be more than one. In this case, I only did it up to the first one, right? So is there a common one? Yes. If there's more than one, what's the smallest one that's common then? So if there's more than one, what's the smallest one? The smallest one in both lists, that appear in both lists, is 20, isn't it? There you see that? That is your least common multiple, would be 20. That's what it means. So if you remember that's what it means, you don't get stumped on it anymore. You just think about things that multiply to get to it, right? But whatever number I have, just do a times table, if you need to, on scratch paper, until you find one that's in both of the lists. See that? The first one that pops up, that's the least one. That's the one you're looking for. Because if this is the least common multiple of these two numbers, if I wrote it as a fraction, like what is 1/4 plus 1/5, now the 4 and the 5 are denominators, aren't they? So what is the least common denominator for these fractions? Well, it's the least common multiple of those denominators, is what I just said, right? What is the least common multiple of 4 and 5? The denominators. 20. So the least common denominator is 20. And that's the number I want to recut the pizzas in. I want this to become a 20. I want that to become a 20. See? And that's the new number you want on the bottom. So the next part's even easier because what do I multiply to 4 to get 20? Oh my gosh, no, we're thinking we did it right here, right? 1, 2, 3, 4, 5, right? So I times this by 5, and that's why I times that by 5. And 1 times 5 is 5. So 1 out of 4 slices is exactly the same as 5 out of 20 slices. And how do I do this one? Well, 5 times 4 is 20. So this one is times 4. So 1 times 4 is 4. And there you go. So 1/4 of a pizza plus 1/5 of a pizza of different sizes is equivalent to what? Cut all the pieces into 20 slicers, right? And I'm going to get 9 of those. And that would be the same. That's how that works. No matter what they are. Now in this case, it was a simple idea here because it was just, this is 4 times 5 and that's 5 times 4. That's not always the case. Okay, there could be a smaller one. So can I do that all the time? Actually, yes, you can. Remember I told you, there's an infinite number of possibilities. So if you are in doubt and you do not know how to find the least common denominator, you can literally take this one and multiply to that one, and take that one and multiply to that one. It will work. It's just not the least one, which means you might have to do something called reducing afterwards. All right? But it will work. No matter what. All right? But finding the least common denominator usually means you can eliminate a lot of extra work at the end. Most of the time. Okay? So if they're unlike, then what we need to do is, so in general, here's your little rule, your little template, if you want to say. If I have A over B plus C over D, then I need to get a common denominator. And what I just said was what? I can just get it by multiplying those two together, right? But if I do that, I have to get equivalency. So this one needs to multiply to D, so the top multiplies to D. And this one multiplies to B. Let's write it this way, and you can see it a little bit better. See how the D's drop out? And you get A over B. See how the B's drop out? And you get C over D. And then you can add the tops. So this is your unlike term process. Well, how do I multiply? Well, I'm sure you multiplying is probably the easiest of them all for you guys. You just simply, if I have two fractions, and I'm going to, doesn't matter what this one, when you multiply, you don't care what the numbers are. You don't care you don't worry, who cares about the denominators? No one knows, no one cares. Doesn't matter. Okay? Only the adding of unlike fractions is the one that causes any kind of extra work. Multiplying, you don't need to change the denominators or anything. You just simply multiply across and create one fraction. Top to top, bottom to bottom. Done. That's it. And then you ought to say that at the end. So that's multiplying. If you want to see an example of that, let's just do 2/3 times, let's go 5/7. Okay, don't overthink it. That's what? 2 times 5? What's 2 times 5? 10. 3 times 7, 21. Done. That's it. For dividing, a little bit more is involved because we don't really divide so much by fractions, but we change it to a multiplication problem. So if I have a fraction divided by another fraction, you need to change it. How do I change it to a multiplication problem? You literally flip over the second fraction and then multiply to this multiplication problem. So you need to flip the second fraction and then multiply. And that's how you do those. The last thing I want to talk about here, let me spell first. You must always reduce your fractions. Always. Don't forget that. You will be docked if your fractions are not reduced. Okay? So how do I reduce? To reduce a fraction is related to multiplication and division. Okay? So let's say I have a fraction. What you want to do is you want to find a common factor other than 1 in the numerator and denominator. Once you have found that, you can reduce that number out. Using the multiplication and division properties. So how does that work? Let's find a fraction that I can reduce. Let's say I did a problem and I got an answer that was 12 over 20. And I want to know, does this reduce? Well, what I'm looking for is now I'm looking for numbers that go into 12 and numbers that go into 20. Okay? And if you can't see the biggest one, find any one. Is there any number that goes into both 12 and into 20 that you can see? Now, you may see one number, you may see other numbers or whatever. Like, for example, we know that 4 goes into 12, and we know that 4 goes into 20. But let's just say, for the sake of argument, that you did not see that one. Well, first off, they're both even. So you should automatically know that at least 2 goes into both of them. So let's just go with that. Let's say we didn't see the 4. Let's just go with the 2. Well, then the concept here is, well, then 2 times what is 12? 2 times 6 is 12. And if 2 goes into 20, well, then 2 times what is 20? Well, 2 times 10 is 20. And what I want you to see here with this multiplication division properties is this thing right here. See, this is now a fraction that comes from a multiplication. See, we have this right here, right? We have something times something, something times something. That's what I have. 2 times 6, 2 times 10. It's in this form. Well, if it's in this form, this rule says I can put it into that form. That's what it says. Remember, this is an equals. A lot of times people think it only goes in that direction. I can do this and I can do that. Well, I can also take something like this and put it like that. I can go either way. Now, we normally do this in our head and we do this quickly, but I'm showing you where it comes from, okay? So this I can break off as 2 divided by 2 times 6 divided by 10. Why would I want to do that? Well, what is 2 divided by 2? This is where the division property comes in. 2 divided by 2 is 1. So this becomes a 1. 1 times 6 over 10. And 1 times any number is just the number. So now I have an equivalency between 12 over 20 and 6 over 10. That's how that works. So I have reduced this fraction. In other words, I've undone the cut up the pizza. I'm starting to put some slices back. I got some tape, and I'm going to put them back together so I get smaller, bigger pieces, but less of them. Well, then I ask, well, can I do it again? If I can do it again, we'll do it again. I can see that there's a 2 in the top and the bottom again. So this is 2 times 3, 2 times 5. And I'm not going to split it apart, but you can see that's the 1 right there, isn't it? So if that becomes a 1, then what's left is what? Is 3 out of 5. That is the fraction reduced. So the whole concept of reducing is finding that number that can turn into the 1. And then whatever's left over is your simplified version. And you keep on going until you can't find anything other than a 1. So there's no numbers that's in both 3 and 5 except the number 1. This answer is reduced. This is the simplest reduced form. All fractions must be reduced. Now, if it's not reduced, in some cases you might be okay. In other cases, I might dock you if if the answer is worth 1 point, you might lose half a point for not having a reduced fraction. Okay, so just make sure you do get in the habit of it. That's where you want to be. So that's fractions. I'm going to go ahead and stop the recording.